Hello guys, welcome back to my channel, Maison African Motives. Still working on the question paper that we had for A-level maths, which was actually the November 2021 session, which is paper 1, pure mathematics. This is Zimsec. So we have got worked until up to question 5, if I'm not mistaken. We're supposed to start from this part. So that is what we had, guys. On question number 5, we are given a question where we are asked to express this whole expression, which is 2x squared plus 3x plus 1 in the form, that is the format that we are given here, where a and b are constants. Okay, so that is actually by completing the square method. That is what you can actually do to attempt this question. So yes, let's just write it here. So we are given this is 5a, if I'm not mistaken. This is 2x squared plus 3x plus 1. Okay, that is plus 3x plus 1 in this case. Okay. So the format that we are given, take note of the format, guys, that we are given in this case. I want us to just get back a little bit. It's a plus b, x plus b in this case. Okay, let me just write it here like this. A is of this nature, that is a into x plus b squared, okay, plus c. That is the format that we are given there. So this can only be achieved if we are to complete the square. So we are going to complete the square in this case. Okay, so remember, guys, by completing the square, that you are supposed to make the coefficient of a squared, which is this one, to be 1. So in this case, we can factor out 2. That means if we divide here, we are going to be left with x squared plus 3 divided by 2 is going to be 3 over 2x plus 1 divided by 2, that's 1 over 2, like this. Okay, so remember that after you have to find half the coefficient of x in this case, which in this case, this is the coefficient of x, and take note with the sign of the number that you have got here, which is 3 over 2. So we need half the coefficient of x, which is 3 over 2. And we have to square this. Okay, so if we have to square this, we are going to obtain something like 3 over 4 squared. Okay, that's 3 over 4 squared in this case. Okay, so what we are going to do is to take out this part here. We are going to have 2 into x plus the square, that is the square here, which is the over 2. That is the one that you're going to, we have to add this. Okay, so it's going to be x squared plus, we write down the middle term as it was, 3 over 2x plus, now we add this square, which is now 3 over 4 squared. All right, so this is what you're going to have. But take note, we added something which is not part of our expression, so we have to subtract that part that we added, which is 3 over 4 to the exponent of 2. In this case, that's what you're going to have at the end. And simplifying this further, we are going to see, we are going to be left out with something of this nature too. Into here, if we are to factor out, like if we are to factorize here, because we are supposed to factorize, and we are actually maintaining this part, guys, from x squared up to this part here. So that means I'm just going to work with those two, because remember, we have to work with this part that has got a square here, this part that has got x squared, and the 3 over 4 squared. So that means taking these two, we are going to be left out with the x plus 3 over 4, everything being squared. All right. Then we simplify this last part, that is half minus 3 over 4 squared. If we are to subtract this, we are going to obtain 1 over 16 from our calculator. And if we multiply this, we are going to be left out with 2 times this bracket is just 2 into x plus 3 over 4, everything squared. Then 2 times minus 1 over 16, this 2 is going to multiply here. It also multiplies here. So we are going to be left out with minus 1 over 8. If we multiply properly on your calculator, it's going to be minus 1 over 8. So that is the format that you are given here, guys, with this format of a into x plus b squared. That is the format that you're given here to find. And the other part of the question, if you have to cross-check, we are now given now to hence or otherwise solve the equation. So hence it's a continuation. Otherwise, you can use any other, you can use any part, quadratic formula, factorization, any part, as long it gives us the exact thing. So I'm just going to continue with the hence because already we have this part here that we have. So to solve this equation, this is now b. So this part here, remember this 2x squared plus 3x plus 1. This one, the 2x squared plus 3x plus 1, this one is the same as the part that we just determined now, which is 2 into x plus 3 over 4, x plus 3 over 4 squared. It was minus 1 over 8. Is that so? Yeah, that is minus. This part here is the same. So to solve the equation, when we are saying this is equal to 0, it means also this part here is supposed to be equal to 0, just like that. Okay, so that is what it simply mean. So let us see what does this part is what is going to happen here. So let's equate this to 0. It's going to be 2 into x plus 3 over 4 squared minus 1 over 8. We equate this to 0, so you can actually transpose this to the other side of the equation so that it can be a positive. So it's going to be 3 over 4 squared, which is equivalent to 1 over 8. So how can we get rid of this 2? Because the 2 is multiplying the bracket. So I can simply get rid of this 2 by dividing both sides by 2. And by doing this, I'm going to be left with the x plus 3 over 4 squared, which is going to give us 1 over 8. This part divided by 2 is going to give us something like 1 over 16. So this is 1 over 16. And I have to take rid of the square, and take note, whenever you're given a square, introduce your square root both sides. So this is a square root. Sorry, I didn't change the marker. So square root here, which is x plus 3 over 4, which is equivalent. Remember, the square root of any number is plus or minus. It's going to be 1 over 4. All right, then let's transpose this to the other side of the equation. Is going to be a negative 3 over 4 plus or minus 1 over 4. So if we are to add first, we are going to be left out with what? Minus 3 over 4 plus 1 over 4 is going to give us minus a half. Or x is going to be minus 1 over 4. This time you work with a minus. So it's minus 3 over 4 minus 1 over 4, which is going to give us a minus 1. That is what you're going to have from your calculator. So that is what we had, guys, from this question. Just to solve, you're done. So let's move on to the other part of the question where we are now given number 6. There is a sector. All right, so let's see what we have got. In the diagram, A, B, and C are 2 points on the circumference of a circle. Center O and radius are the angle A or B. A or B, this one is theta radians. So here they are saying there is an angle which is referred as theta radians. C is the midpoint. C is the midpoint of OA. So this is the midpoint, that is it is in between. So which means we've got equal distance here from O to C, and from C to A, we've got equal distance. And what else are we also given? We're given that R is the radius of the circle, and as you can see, from O to B and O to R, also this is the radius of the circle, which is also R then. And we are also given the length of BC. The length of BC is Y, this length here, okay, is Y. And the length of arc BA is T. The length of the arc BA, that is this from B to A, that is the arc that you're given. We are given that is what? As T. So let's see what you're given, guys. On the first question is to express Y squared in terms of R and theta. Okay, express Y squared in terms of R and theta. So normally on these typical questions, guys, we have to try by all means to use the information that you're given, because like you're not, it's not like something that is direct. Okay, so you have to choose something that can help you to simplify that. Okay, looking at this triangle actually here, I'm going to use this triangle to say that let me take this triangle from B like this to O to C like this one. There's something of this nature. This angle is not 90 degrees. We are not specific that it's 90, so we do not know this angle. But we know that this angle is theta radians. This is B, this is C, this is O, and we say this is Y. This is the radius. Okay, and here we said from O to C is the same as C to A. So which means OC is equal to CA, which is equal to radius over 2, because the whole of this line is the radius. So it's going to be R over 2. From O to C, it is going to be R over 2 like that. Okay. So that means using this diagram or working with this diagram that I'm given, I can express y squared because having a non-right angle triangle, that means I can apply cosine rule. Remember our cosine rule, guys. Let us just do the calculation down here. Okay, let us just do a calculation here. So this is 6. So remember our cosine rule to find the side is a squared, which is equal to b squared plus c squared minus 2bc cos of what? Cos of a. All right, so from our triangle, I want us to see that this is our a. This part here, the part that is opposite the angle, this one, your y here is going to be y squared, and this is your a, this is your b, this is your c, and we say this is our a. So y squared is equal to, we have got r and r over 2 there. So I hope we've got the values, guys, so that it won't disturb us. So our a is going to be y squared, which is equal to b and c. We said those are the sides which was r there and r over 2. So it's going to be r squared plus r over 2 squared minus 2 times b times, which is the same, 2 times r over 2 cos a, which is the theta here. So it's going to be cos theta. Okay. So that means y squared is going to be r squared plus, if you simplify, this is r squared over 4. That is 2 squared is 4 there. Minus, this can cancel here. You'll be left with r squared cos of theta. Then we can collect like term. This is same as 1. This is same as 1 over 4. So 1 plus 1 over 4 is going to give us 5 over 4. So this is 5 over 4 r squared minus r squared cos theta, which is y squared. So take note, this cannot be simplified unless maybe you can factor out r, but you can actually leave this part like this already. We have expressed this y squared in terms of r and theta. That was the question there. Let's take our question and see what we're given. The question was to express y squared in terms of r and theta. Okay, then on B, or otherwise show that if theta is small, take note, if theta is small, therefore we are going to obtain this part, y squared is going to approximate to this expression. All right, and that's 4 marks for that. Okay, so let's see, guys, what we are going to do from this part, because it actually is a continuation from this part. If theta is small, let's see our item 2 here. So take note that when theta is small, we are supposed to have this expression, y squared is going to approximate to, we are given it's 1 over 4 r squared plus t squared over 2. Okay, so that is what you're given. So what are you going to do, guys? Okay, let us start by the statement when theta is what? If theta is small. Okay, so let's get back here and do our approximations. We know that from our cos theta here, we are going to work with cos theta. We know that if theta is small, cos theta approximate to, okay, let me write it here. Cos theta approximates to 1 minus theta squared over 2. If theta is what? If theta is small. Okay, so that's an advantage that you're going to take. In place of cos theta, let us substitute with this. So it means y squared is going to be 5 over 4 r squared minus r squared into theta, into cos theta. The whole of this part here, which is cos theta, is now to be substituted with 1 minus theta squared over 2. So that means someone can actually work something here until we have our y squared in that format. Okay, so what actually happened, that is present now. Okay, I want us to see something here. I want us to see something. If we are to expand, okay, let's expand first, guys. Let's expand and see what you're going to have, because our answer, there's something that I'm seeing on our answer. So it's going to be 5 r squared, and if we expand, this is going to be minus r squared. Expand minus and minus here, that's a plus, so it's going to be plus r squared theta squared over 2, of which we can just write this as r squared times theta squared over 2, like that. Okay, why do I want to, okay, why am I trying to write this in this format? Okay, I'll explain it later. Let us collect like terms first. Here I've got like terms. These two are like terms. This is same as 1 here, so it's 5 over 4 minus 1. Okay, and this is 1 over 4, so it's going to be 1 over 4 r squared plus, here I said we can separate like this, which is going to be r squared times theta squared over 2. Okay, it's just one and the same thing here. And if we are to cross-check, our answer is in terms of what? Is in terms of t. So what actually happened here? Because that is what we have to ask ourselves. What actually happened here? Because this 1 over 4 r squared is there. This is the one that we have here. 1 over 4 r squared. This one, we already have this. But here, if we are to cross-check, our answer is in terms of r, in terms of theta. But it is needed here in terms of what? In terms of t. So what actually happened that this was in terms of t? Okay, let's get back where t is on our diagram here and see what actually happened. This is where we've got t here from A to B, which is the length of the arc. Remember, we said this is the length of arc, and we know that length of arc is equal to r theta. That is radius times what? Radius times theta. And in this case, the length of arc in this case is t. So you're saying t is equal to r theta. So that means I can actually make r to be the subject or whatever that I want. Okay, but let us make r to be the subject, divide by theta here, divide by theta. So which means I can cancel this, which means r is equal to t over theta. That is what we have for our radius here. So radius is theta or t over theta. That is our radius. Okay. So we are saying here radius is equal to t over theta. That is what we got from this expression. So let us substitute our radius now in terms of t. So it's going to be y squared is equal to 1 over 4 r squared plus, here we've got r squared, and we said r is t over theta. So if we square this, because that one is r squared, it is going to give us t squared over theta squared. So this is going to be t squared over theta squared times theta squared over 2. Okay, so theta squared and theta squared can cancel each other. That means here y squared is going to actually approximate to this one. Is actually an approximation here. 1 over 4 r squared plus this is cancelled, so it's going to be t squared over 2. That's what you're going to have. So once we, from this stage here, once we say our theta is small, we are supposed to use approximation here, approximation there, approximation, approximates to accept. So that's what you're going to have throughout the answer. So as you can see, that is what we are being given here, and that's what we got. So it means we are in the right direction. Okay, let's see the other question that we are given, which is question 7. Question 7. Okay, question 7 is actually proved by induction. Okay, this is mathematical induction, guys. Take note of your induction. Okay, let me just write the question down here. This is number 7. Let's just put it on this page. So on number 7 there, we are given this case where we have got matrix A. Take note, we are given matrix A, which was equivalent to 3 4 -1 like this. So this is your matrix, and a to the power of n, which is equivalent to 2n plus 1 in minus n, and we have got 4n, and we have got 1 minus 2n. So this is 4n. Let me just try to write it nice here. If math was done by ladies, it was going to be much easier. It was going to be much smarter than when it is done by us men, you see, the way that we write and so forth. But anyways, I hope we can clearly see here. So this is your matrix A to the power of n. All right, so if we can cross-check properly here, we are going to see that we have got, in this case, we want to prove this by induction. So the first step is actually to let our Pn, to just write this as our Pn be the statement that we have got here. Just substituting here because this is your A. So we can just let this be an approximation of A to the exponent of n, which is equivalent to this part of 2n plus 1 minus n 4n 1 minus 2n. So that's what you're going to have in this case. And if we are to just cross-check here, we are going to see that here, if we are to write this in terms of A, we have got our matrix A. So why is it that we can just substitute, isn't it, than just rewriting this and just rewriting? Let us substitute our matrix A. Our matrix A is 3, 4, minus 1, minus 1, this part. So it means to the exponent of n to the power of n like this, it is going to give us 2n plus 1 minus n, 4n, 1 minus 2n. Just writing this so that we do not have problems when simplifying now. So let's get back to the question. We know that if we are to let n be equal to 1, then it must be true. So here, let's just write when n is equal to 1. Okay, that means P1 must be true. P1 must be true. Okay, so if this is 1 here, we can substitute 1 here. So let's see what you're going to have. If this is 1 here, it means there's nothing that is going to affect. It's just going to remain like that here. I'm saying if this is a 1 here, it's just going to remain like that, as you can see. So that means here we are just going to remain with something like 3 minus 1, 4 minus 1, like this, to the power of 1, which is just like that, which is equal to, here in place of n, we substitute 1, we substitute 1, wherever there is n, we substitute 1, so it's going to be 2 plus 1, which is 3, minus 1 here, 4 times 1, which is 4, 1 minus 2, which is minus 1. As we can see, this is true, okay, which is true. So this is actually true. Okay, let's move on to the other stage. We can let our n be equal to k. So now when n is equal to k, it means pk is also true. Is also true, this part. Okay, so if this is true, this one is just a matter of substituting in place of what? In place of n here, we just substitute, or we just put k wherever there is n. Sorry for that. Wherever there is n here, we are going to substitute k, we are going to put k, we are going to put k wherever there is n. So I think we understand what I'm trying to say. So if we are to cross-check, our final answer, therefore, is going to be like this. Remember, it was to the exponent of n. It was 3 minus 1, 4 minus 1 to the exponent, or to the power of n. So it's going to be to the exponent of k, which is equal to, in this case, we are going to have what? 2k plus 1, because it was 2n, and this one, it was minus k, so it's minus k, 4k, and we have got 1 minus 2k, like this. Okay, so that's what you're going to have in this case. Okay, so this one you're just saying it's an assumption that is going to be, it's going to be true. Okay, Then let's move on when n is equal to k plus 1. So when n is equal to k plus 1. Okay, so we want to see on this part that when n is equal to k plus 1, then it like everything must be true. Okay, so we are going to prove this, so you can just write I shall prove. Okay, I shall prove that pk plus 1 is also true. So this will be pk plus 1 is also true. All right, so let's see what you're going to have in this case. So remember guys, our exponent here, now it is going to be k plus 1 here. We are going to have what? K plus 1 on this part here. It's going to be k plus 1. Okay, that means we are going to have something of this nature. The matrix as it was 3 minus 1, 4 minus 1, like this, to the exponent of k plus 1. Okay, now if we are to cross-check, if this is now k plus 1, it means in place of n here, I want you to cross-check here, wherever there is n, you are going to substitute k plus 1. So we had 2n plus 1. So in place of this n here, you are going to substitute k plus 1. Wherever there is n, you substitute k plus 1. Okay, so that means here it is going to give us 2 into n, which is 2 into k plus 1, and we had a plus 1. Okay, we just substitute, and the other one was minus n, so it is going to be minus k plus 1. Okay, the other one was 4n, so it's going to be 4 into k plus 1, and the other one was 1 minus 2k, so it's going to be 1 minus 2 into k plus 1. So here you are just writing this presentation, like on this presentation you are just substituting wherever there is what n here, you are substituting k plus 1. Okay, then this is what you're supposed to do. You're supposed to prove now that this part here, when you expand this part, it must give you this expression. That is what you're supposed to now prove. Okay, so how are you going to prove this? How are you going to prove? That is the question now, to say, how are you going to prove that these two are actually the same? Okay, let us take the left hand side. In this case, let us work from the left hand side. Okay, on the left hand side, this is what we have, guys. We have got 3 minus 1, 4 minus 1. This is what we have on the left side, which is to the exponent of k plus 1. Okay, if I am to expand this from our laws of exponents, we know that this is the same because here we are adding. These two are adding. It means we had two matrices which were multiplying each other, which are the same to the exponent of what? To the exponent of k, which was multiplying 3, 4 minus 1 minus 1 to the exponent of 1, of which to the exponent of 1 simply means it's just like that. So these are the two matrices that we are multiplying, and that is why we have to write in this format that we are given there. Now the question is, if this was a multiplication and this is what we have, how then did we manage to obtain this part of the what? This part of the brackets that we have? Okay, so we are going back here. Okay, when we assume that in place of k, when we made in place of k to say this is, we are just assuming it's true. So we can substitute this matrix with the equivalent, because we have got an equivalent of this matrix here, which is this assumption that we had. So we're going to take our assumption, which is 2k plus 1, whatever that we had, in place of what? In place of this matrix that we have. So let's take that part of our assumption, which is 2k plus 1. Remember, this was 2k plus 1. Sorry for that. Let me just remove this part here. Okay, so we had 2k plus 1. That is, we are writing the matrix now, the one that we had on our assumption, which is 2k plus 1 minus k. The other part is minus k, if I'm not mistaken here. All right, this minus k, 4k, and 1 minus 2k. Okay, so this is 4k. Okay, this is 4k, 1 minus 2k. So this is the equivalent to this matrix with an exponent of k. And this matrix we just rewrite as it is, which is 3 minus 1. The one that we are given, we just rewrite as it was. All right. So rewriting this, let us now perform our matrix multiplication, where we know that it's row by column. So we have got this row here by this column. Okay, so it's 2k plus 1 by 3, which is going to be 3 into 2k plus 1 plus 4 times k, which is minus 4k in this case. Okay, so that's what you're going to have. Then this row and this column, take note, it's a minus. So it's minus 1 multiplying 2k plus 1. Then plus here we've got minus k times minus k, which is a plus k. Okay. Let's move on to the other part. We move on to this row. This time we are working with this row and this column. So it's again 3 multiplying 4k. So this one we can just multiply direct, guys. 3 times 4k, which is 12k. Okay, so this one you're going to obtain 12k in this case. Okay, then plus 4 is going to multiply the whole part of 1 minus 2k, in this case, this part here. Okay, we are done. We move on to this column. So it's minus 1 times 4, which is minus 4k. Minus 1 is going to multiply this bracket. So take note, it's a plus, and there is going to be a minus 1 multiplying 1 minus 2k. So this one is just a minus, just like ordinary values. So we can simplify further this part. So if we are to simplify further, we are going to obtain 3 by 2 here, which is 6k. 3 times 1 here, which is 3. Plus and minus is going to be minus 4k. So we're going to have minus 4k here. We move on here. This is 12k. So we are going to obtain 12k. 4 times 1, which is 4. 4 times minus 2, which is minus 8. So this is minus 8k. All right. We move on here. We multiply by minus 1. So it's minus 1 times 2, which is minus 2. K, this is minus 2k. Minus 1 times times 1, which is minus 1 plus k. Okay. And here we have got 4k. Plus and minus, this is a minus, so it's minus times 1, which is minus 1 plus 2k. All right, so you can collect like terms and simplify further, which is 6 minus 4, that is 2k. So we are going to obtain 2k plus 3 minus k plus minus 2k plus k, which is minus k minus 1. Here we can collect like terms, which is 4k here, 8 minus 12 minus 8, that is 4k plus 4. All right, then we move on here. We've got minus 4k plus 2k, that is minus 4 plus 2, which is going to give us something like negative 4 there. So that is a negative 4, the one that you're going to obtain in this case. All right, so that's a negative 2. Negative 2k. All right, so we've got negative 2k, negative 1, like this. All right, then let's see what actually happened, because remember, us, we are supposed to write this expression here. We are supposed to obtain this part here. How then was it written as 2 into k plus 1? Can we actually obtain this part from this? If you are to cross check here, actually we can have this here. If we are to expand, this 3 here is same as what? It is same as a 2k plus 2 plus 1, like this. So here 2 is common, so you can factor out 2, which is k plus 1. Here we are going to be k plus 1, then plus 1. So as you can see, it's one and the same thing. So it's 2 into k plus 1. Okay, so this is k here plus 1 plus 1. Okay, what happened here? as you can see, it's just a matter of factoring out the negative, which was common here, because negative is common on these two. So you can just factor out negative, which is k plus 1. And here 4 is common. It was just a matter of factoring out 4, which is k plus 1. Okay, then we move on to this part. What actually happened, our answer was 1 minus 2k plus 1. So if you have to cross check here, we have to expand. In this case, we had to expand this one here. We had to interchange because this is negative 1. Okay, but our answer is supposed to be 1 minus. So we had to factor out minus first. If you have to factor out a negative, okay, let's start by this value here. We want to obtain a factor of what? Of 2. So in this case, we can actually ask ourselves that if I am to write this as 1 minus 1, okay, this can be 1 minus 1 like this. Minus 1 is one that we have got, and we have got minus 2k. Okay, so if we are to write in terms of 1, we can actually remain with something like this. 1 minus, we want to remain with this one, take note. So it's going to be minus 2 because it's supposed to be minus 1. So we are saying 1 minus 2. It's actually same as minus 1 and minus 2k. We haven't changed anything, but we are just rewriting as what? As minus 1. And these two here, we can factor out what? Minus 2 because it's common. So if I factor out minus 2 here, I'm going to remain with 1 plus k like this. And 1 plus k is same as what? Is same as k plus 1. So it means this part here is actually the same as 1 minus 2 into k plus 1, which is actually true. And we are going to see that that's the same thing that we had here, which is what? Which is true in this case. And we are saying this part is actually true, okay, which is true. So that's how actually we work out this, and you put in your conclusion. In this case, I don't know the conclusion that you're going to work with, because remember I told you on mathematical induction that there are so many conclusions that you can have, and I gave you a lot, I listed a lot of conclusions there, so you can actually pick the one that is best for you. According to you guys, you just say, okay, this is the best one, then you pick from there. But that's what we actually had from this particular question. So those are the typical questions that you can have, especially on this type of a question on induction. Okay, the other part is solve this equation, giving the answer to correct to 3 significant figures. Okay, so guys, it's just a matter of solving here, where we can actually work with laws of exponents, depending with the question how it is given. Okay, so here let us first write down our question. This is 8a. We are given 2 to the exponent of x plus 1, everything over 2 to the exponent of x minus 1, which is equal to 5. Okay, so in order for us to solve this question, let us start maybe by expanding here, this removing of fractions, that is writing in its simplest form. So we can expand. This part is going to be 2 to the exponent of x plus 1, which is equal to 5, is going to affect everything here on 2 to the exponent of x. So we can write this as 5 into 2 to the exponent of x minus 1 like this. Okay. Now what can we do? We can expand further so that we can be able to collect like terms. 2 to the exponent of x plus 1 is equivalent to, here is going to be 5 by 2 to the exponent of x minus 5 times 1, which is 5. Okay, so this is just a multiplication, so you can even put it in a bracket, then collect like terms. Minus 5 to this side is going to be a plus, so it's 1 plus 5, which is equal to 5, 2 to the exponent of x minus 2 to the exponent of x, because this one was a plus. So the moment it crosses the equal sign here, it becomes what? A negative. Okay. So 1 plus 5, that's going to give us something like 6. So this is 6. And here we are subtracting. This is to the exponent of x, the same as there is a 1 here. So it's 5 minus 1, which is 4. So we're going to have 4 into 2 to the exponent of x. Okay, so we can divide by 4. We can divide by 4 here. That means 2 to the exponent of x is going to give us 6 over 4. Okay, and 6 over 4 is same as 3 over 2. So at this stage, guys, we are now back to your laws of logarithm, where you can introduce logarithms here, which is log. So it can be ln 2 to the exponent of x, or log, depend with which one are you going to use, which is ln 3 over 2. Okay, I want to find x. So what am I going to do? I'm going to drop out this x. Is going to be x ln of 2, which is equivalent to ln 3 over 2 in this case. Okay, so divide by ln 2, divide by ln 2, both sides. This is going to cancel. So x is going to give us, we simplify further, and this is going to be something like 0, 0.584, something like that, 962, and so forth. So therefore, our x is going to be 0, 0.585. All right, so that was the idea there of this question. So guys, answer the question. Always try by all means to answer the question that you are given. It's not about just writing whatever, that it's about answering the question the way that you're given. Okay, then on the other part there, we are given to solve the inequality now. That's the inequality, and it's actually 5 marks for that, to solve this inequality on B. So let's just see what we have got there on solving the inequality. Okay, so there we are given, this is actually B. Let me try to use this one. It's much better for me than the black one. Okay, so this is 3x minus 3, like this, which is greater than 2. We have got 3x plus 1. Okay, so take note, whenever you're given the modulus, how do you remove this modulus? You have to square everything on both sides. So it's going to be x minus 3 squared is greater than 2 squared. We square everything, is 3x plus 1 squared. Okay, so remember, from your brackets, if you expand this bracket, we are going to obtain x squared minus 6x plus 9, which is greater than 2 squared, which is 4. We expand this bracket, we are going to obtain 9x squared, 3 times 1, which is 3 times 2, which is 6x plus 1 squared, which is 1. Okay, so we can expand the brackets further so that we can be able to collect like terms. So it's 4 times 9, which is 36x squared, 4 times 6, 4 and 6, which is 24x, then 4 times 1, which is 4. Okay, so there we can collect like terms to one side of the equation. So it's 36 to this side, which is going to be a minus. So it's 1 minus 36, which is minus 35 x squared. Minus 24 to this side is going to be a minus. So it's minus 6 minus 24, which is minus 30x. Okay, 4 to this side of the equation is going to be a minus, so it's 9 minus 4, which is going to be plus 5, is greater than a 0 here. So we can reduce our equation before our inequality, sorry, before we solve it. So we can reduce here, we can actually divide out by -5, by -5, by -5, by -5 throughout, so that we just avoid working with a negative. So it's 7x squared, negative and negative, which is a positive, 6x, negative into positive, which is -1 here. And the moment we divide by a negative here, the inequality sign is going to change. And this is what we are left with, and we know that we have to find the critical values here by solving the normal equation, which is this equation equate to 0. It's now a normal equation, just a quadratic equation. You can use factorization, completing the square. I don't know which method I'm gonna use here, applying factorization is going to be negative 7x squared. And what are the factors that we have here that we're going to multiply to get minus 7x squared? But when we add, we are going to have 6x. So it's 7 and what? 1. Okay, so that's 7x squared plus 7x minus x minus 1 is equal to 0 here. Factor out 7x, we are going to be left out with x plus 1 minus 1, which is going to give us x plus 1, which is equal to 0 here. Take x plus 1 into 7x minus 1, equate this to 0. Solve these values for x, so which means your x in this case is going to give you a negative 1, or x is going to give you 1 over 7. So this is x is equal to minus 1 or 1 over 7. Okay. Then according to the function, this is a positive. So remember, if it is a positive, it's going to be a smiley shape like this one. That's a positive. So that's what you're going to have. In this case, it's going to be a smiley shape. And these are the values of x that we are going to have, which is from minus 1 to 1 over 7. So this is minus 1 and this is 1 over 7. So if we are to cross-check, this part is less than our function, which is your f of x in this case is less than 0. So when it is less than 0, it means we are referring to this region that is below the x-axis. This region here is the one that we are referring to. So if we are referring to this region, it means our x is going to be in between minus 1 and 7. So our x is going to be greater than minus 1 but less than 1 over 7. Okay, so that's what you're going to obtain in this case as our final answer. And definitely this x is actually part of what is an element of the real numbers that we have. So these are the typical questions, guys. As you can see, it's actually simple. Just it's a matter of understanding the equation that you're given and simplifying as much as you can. Okay, let's see the other part of the question that we are given, which is where are we now? Okay, number 9, we are given that x is so small that x to the exponent of 4 is x to the exponent of 4 and the higher powers can be neglected, which means they are not going to be counted. Okay, show that e to the exponent of x over 1 is going to approximate to this. And okay, so what can we do, guys? Here we know that from our Maclaurin's rule there, or the theorems that we have, we can apply the first derivative, second derivative, and so forth, where we know that this is number 9. Okay, so let's just write where we know that our f of x can be given by f of 0 plus x into the first derivative, but substituting the value of 0 here, and it's x squared over 2 factorial, the second derivative, plus x to the exponent of 3 over 3 factorial, and so forth. So this one will be the third derivative, and so on and so on and so on and so on. So here, let us see our f of x, because we are given our f of x here. This is our we are going to take this as our f of x, which is the function that we are given here, guys. Let's see. We are just going to use this as our f of x, which is e to the exponent of x. Okay, this part here of e to the exponent of x over 1 plus x. Okay, so let's take that part and see what we're going to have. All right, so we are going to just write this as e. It was e to the exponent of x over e to the exponent of x over 1 plus x. Okay, so what if we can rewrite this as e to the exponent of x into 1 plus x to the exponent of negative 1, like this, because we know that this is just one and the same thing, and if you write it on top, it will be to the exponent of negative 1. At least it can actually help us, guys, to simplify as much as we can. So how now are we going to simplify this? That is the question. Okay, if I am to take the first part, okay, I want to take the first part here. All right, let's take our x to the exponent of -1 as our, like, we can take our f of x to be e, because normally e is the part that we can see that it doesn't like affect us. So if we had to work with e on our derivatives, then the x to the exponent, or 1 plus x, we can actually apply our binomial theorem there. Yeah, it can actually help us. Okay, so let's take our f of x in this case to be e, so that at least it can help us, which means f of 0 here is going to be a 1. Okay, so we are going to have our f of 0, which is a 1. We move on to the first derivative. So as you can see, e does not change. It's going to be e to the exponent of x throughout. So that means also the f prime 0 here is going to be a 1 also. So it's going to be like that throughout, which is e to the exponent of x, and okay, something like that. So guys, e is going to be like that throughout. Okay. So that means here there's nothing that we can actually get. It's going to repeat like that. Okay, so the e to the exponent of x is going to repeat. Then let's expand the remaining part, 1 plus x to the exponent of -1. Applying our binomial there is going to be like this. Let's just write it here. 1 plus x to the exponent of what? To the exponent of -1. So this is 1 plus x to the exponent of -1. Remember that if you are given a plus x to the exponent of n is going to be a to the exponent of n plus n. A here is going to be n, and this is a to the exponent of n minus 1, x plus n minus n by n minus 1, and so forth. A to the exponent of n minus 2 x squared over 2 factorial, and so forth and so. So that is the concept that you're just going to apply, but we just apply this. At least we can just apply to 3 brackets so that it can help us. Yeah, let's just apply to 3 terms. Okay, because anything that is above 4 is considered to be neglected. Anything that is above 4, neglect that. So let us expand to the exponent of 3. So this is going to be 1 to the exponent of -1, plus we drop the exponent here, which is -1. 1 to the exponent, if we subtract this, is going to be -2 times x. Okay, plus -1. Okay, sorry guys, this thing wants me to be, it actually needs me to write in slowly, but just imagine guys, if I write slowly, I'm going to finish out. Am I going to finish? Okay, so this will be a -1 here. It's fine. So it's -1 by -2. We drop the exponent here, and it is now -1. We subtract 1 now, it's -3. Okay, x is going to increase, so it's now to the exponent of 2 over 2 factorial. We move on, plus -1. We drop all those exponents. So we have got -2 here, the one that we already have. If we drop this exponent, it will be -3. And it's going to be -1 here to the exponent of -4. It's now -4. If we subtract, x is increasing, so it will be x now to the exponent of 3 over 3 factorial, plus, and so on and so on and so on. Okay. So what are you going to have, guys, from our calculators? This is 1 here, and this is -x. Okay, and if you simplify here properly from your calculator, it's going to be plus x squared. This will be plus x squared. Okay, so it's going to be plus x squared here. Okay, negative and negative. And this, if we simplify the other part, is going to be minus x to the exponent of 3. Okay, so that's what we are going to obtain in this case. Okay, if we simplify properly there. So guys, take note about how you simplify. So this one will be and so on, but that's what we are having from 1 plus x to the exponent of -1. Okay, here is fine. We got an expression, at least that we can expand. What about here? Okay, here we didn't have an expression, so it means, guys, we need an expression here. We need an expression at least that we are going to use so that these two can expand each other. Okay, so let me just remove this part, guys. Okay, so here let us take this part. Sorry, let us take this part here. We said from our maclaurin's we have got f of x, so let us just finish out so that we can expand everything. So f of x is going to be, hey, Jesus Christ. Okay, something of this nature here. So it's going to be f of x, which is equal to f of 0 here. We obtained 1, so it's going to be 1. Here is f of 0, everything is 1, so it's just going to be 1 times x, which is x here. 1 times x squared over 2, so it's going to be x squared over 2. Yeah, if we write this, it's going to be x squared over 2. 2 factorial is going to be 2 plus everything, everything here is 1, so you're simply multiplying by 1, so it's going to be x to the exponent of 3. 3 factorial, which is 6, so it's going to be x to the exponent of 3 over 6 plus, and so on and so on and so on. Okay, so f of x, which is e to the exponent of x. This is for e to the exponent of x, this one, okay? This is for e to the exponent of x. So we are now going to multiply the resultant now, because we said we have got a product of 2 here, the product of e to the exponent of x into 1 plus x to the exponent of minus 1. So e to the exponent of x gave us this expression here. Let us write our expression. It gave us 1 plus x squared over 2 plus x squared over 2 plus x to the exponent of 3 over 8. This is what we got from e to the exponent of x. From 1 plus x to the exponent of minus 1 from our binomial there, we got this expression, this one. So we're going to take this part and multiply the 2. So we got 1 minus x, okay, plus x squared, okay, minus x to the exponent of 3, okay, plus, and so on and so on and so on. Okay, so now let's expand, guys. We've got 1 here and 1, which is going to give us 1 and minus x, which is minus x, 1 and x squared, which is x squared, minus x to the exponent of 3. We are done with 1. We move on to x, so it's x here. We start with 1, x and 1. That is x and minus x here, which is minus x squared. X and minus and plus x squared is going to be x to the exponent of 3. X and x there, which is minus x to the exponent of 4. So this one is going to be neglected. We are done with x. We move on to x squared over 2. It starts with 1 here, so it's going to be plus x squared over 2 minus x cubed over 2. Here's x and x. Okay, the x here is going to give us to the exponent of 4 here, this x squared, and this is now to the exponent of 4. So there's no need for us to write this because we said we are supposed to neglect this. So let us leave it like that. Okay, let us move on to x to the exponent of 3 over 8. Multiply it by 1 here is going to be x to the exponent of 3 over 8. Times x here. As you can see, there's x1 and there's x3 here, so it's going to give us to the exponent of 4. So let's leave it like that. So now we have to combine our terms, collect like terms. We have got 1 here. Let us move on to this minus x here plus x, that's a 0 here. So which means these two are going to cancel each other. As we can see, minus x and x there, that's a 0 there. Okay, then let's move on. X squared, this is 1 here. X squared, so this is x squared minus x squared. It cancels each other, so we are going to be left with this one, x squared over 2. So we are going to be left with x squared over 2. We move on to x cubed minus x cubed plus x cubed. This one cancels each other. So we are going to be left with these two here, minus 1 over 2 x cubed plus 1 over 8. So we are adding these two, minus 1 over 2 plus 1 over 8. Okay, so if we add these two, do we still have another x here? Okay, that's what you're going to have in this case, and it's going to be minus 1 over 3. Is this the one that we are obtaining, guys? Or we are having something. How many terms were we given here? Let's cross-check the terms that we are given. How many terms did we have? And also this of calculators, guys, and so forth. So sometimes you have to take note about that. How many terms we have? So here we need up to the exponent of 3. Okay, up to the exponent of 3. That means there's a term that is missing, because here there's a term that is missing. Let's cross-check our x squared, our x to the exponent of 3 first. Okay, let's just try to be fast. All right. Even exceeding here. All right, here, guys, it's actually 3x to the exponent of 3 factorial, which is 8. This one, which is 6 here. 3 factorial. Here it's 6. Okay, I'm seeing here 6 actually here. Okay, so this is, yeah, it can make sense now, which means all the terms are there. This is 6 here. I hope someone saw that and was like, oh, what is happening here? It's a 6 there. So if we subtract this, it's going to be minus 1 over 3, yeah, which is x to the exponent of x. Now it can make sense. Over 3 over 8, it's now 6 there, so it's going to be over 3. Yeah, now it can actually make sense. So that is going to be the approximation at the end, and as you can see, it's actually the same thing that we had there. So that's how you actually attempt these typical questions, guys. A matter of expanding. So as you can see, we had to separate this. We worked with e to the exponent of x, and we worked with the 1 plus x to the exponent of minus 1 separately. Okay. Now the question is to evaluate or to simplify e to the exponent of 0, let's see here. That's e to the exponent of 0,01 over 1,01 to 7. Guys, let's imagine how many digits we have to count off there. But anyways, what you simply do is that you have to work out from this or b. Okay, we want to simplify e to the exponent of 0,01 over 1,01 like this. Okay, if you are to cross-check previously, we had something like this, e to the exponent of x over 1 plus x here. So this is x here, which is 0,01. This is 1,01. 1,01 is same as 1 plus 0,01. So it means this is our x, this one. This is our x. So in place of x, we are going to suppose this is what we got. So we're just going to substitute here. In place of x, we are going to substitute what 0,01 here in place of x. So it means this is going to actually approximate to, we are just substituting on this. It's a continuation. Okay, so it's 1 plus, it's going to be 1 plus, this is x squared, and our x is what we said, our x in this case is going to be 0,01. So it will be 0,01 to the exponent of 2, everything over 2. This is over 2 minus x, which is 0,01 to the exponent of 3, everything over 3, and so forth. So that is going to be our approximation. And this, from our calculator, we are going to obtain something like 1,00. This is 0 here, and there are 4 of them, 0 again, 0 again, 496, something like that, 67, something of this nature. Okay, so we need 7 digits after the comma. So which means we are going to have 1, 2, 3, 4, 5, 6, 7. So this 6 can actually change this because it's above 5. So our answer is going to be 1,00,00497. So that's what you're going to have in this case. That's our B. So these are the typical questions and how you're supposed to attempt them, guys. As you can see, it's easier. It's easier if you work with more question papers or more revisions. That way you have to get rid of, and you actually see how that it's a matter of it's like a repetition that will be taking place, something of that nature. So it's actually very, very important for you to understand this. Okay, let's just try and see our question 11. what we have got, question 10 is actually question 10. Yeah, let's see this question, then we shall have the next part on our next class. We are given f of x, and we are to sketch. Okay, we want to sketch these two functions. Okay, so let's see how are they going to be like at the end. Okay, did I skip? Okay, let me just use this page here. Okay, so this was number 10, where we are given f of x. So let us start with our f of x, which is equivalent to 2 minus x bar here. Here simply means x is taken as a positive in this case. Okay, so you even if you don't understand this, you can actually just use your table here. When x is a positive, we've got x and y here, 1 2 3 4, something like this nature. Okay, so let's just put in our values here. We can just take two values, -2, -1, 0, 1, and 2. Okay, so when x is -2 here, when x is -2, it will be, x is always taken as a positive. Yes, it's -2, but the modulus means it's a positive. So it's 2 minus 2, which is a 0 here. When x is -1, it's taken as a positive. So it's 2 minus 1, which is a 1 here. When x is a 0, it's 2 minus 0. So it's just taken as a positive throughout. So you're going to see that when x is 1, it's going to be 2 minus 1, which is 1. When x is 2, it's 2 minus 2, which is 0. So it's just taken as a positive throughout. That is what the modulus actually mean. Okay, guys. Okay, it's fine. Let me see, what am I going to do? It's fine. Let me just do this way. So we had something here that was in between there. All right, and we said 2, we ended up at 2. Where's this one coming from now? Okay, so this one is not there. Okay, so these are the values that you can actually use if you're like having a confusion, like what is happening here. We said when x is a 0, here's 2, guys. When x is 0, it's a 2 there. Okay, that's a 2 here. All right, I hope someone saw that this is a 2 here, because you are simply subtracting 2 minus 0, that's a 2. So it's going to be at 2. So if you have to cross-check, our sketch is going to be of this nature. We are going to have something like this. Guys, the way I'm drawing this, it actually needs someone who is now used to this. Let me just try and do some techniques here, guys, and see if I'm going to win. But definitely I must win. I must win. So let's put it this way. I'm just going to make my artificial line here. Okay, so that's my line, and another one here. Yeah, we can win. Actually, we can win. Okay, something of this nature. Yes, so that is what we wanted here. And let's just put our points, or you can just have our x and y axis, our x and our y here. Is this the one that it's too much like they're the same? These ones, they're just like the same. Okay, so our y-intercept definitely is going to be at what? At 2 here, and it crosses, so it's going to be like this, and another one like this. Okay, so this is what we are going to have. This is 2. And in the x-axis, that is at -2 here and at 2. So that's our function, and this is a 0 here. So that's what you're going to have, something of that nature. So that's it, guys. So this will be 2 minus x, and this will be modulus 2 minus 2 bar, like that. Okay, then the other part was actually a straight line. A gx is equal to what? A third x. So gx is a third x plus 1. So we can actually say when x is equal to 0, y is equal to 1. When x is equal to 0 here, y is equal to 1. And when y is equal to 0, x is going to be what? X is going to be 1, because -3, because this is -1 is equal to a third x. Okay, so if you cross multiply here, we are going to see that -3 is equal to x. So x is going to be -3. So this one cuts at -3 and 1. So it's going to be somewhere. Hey guys, forgive me on these sketches. It's not that easy. It needs practice, a lot of practice in order to use this thing, but I'm going to learn as much. All right, but it's like this. Okay, so it's going to cut at this point and also at this point. So it's going to cross these points here. This is your -3, this is your 1 here, something like that. So this is your gx, guys. This is our gx, and this is our f of x. Okay, it was something like that. This is just a sketch. If you have to cross check, it's just a sketch. And yeah, nothing much, just a sketch. You can even just know this even now without this table. You just sketch it down and you'll be done. Okay, now let's see the other question that we are given now on this part, which is on the item B. So actually item B here, our item B here. We are now given, find the coordinates of the points of intersection. So take note, these are the points of intersection of f of x and gx. Whenever you're dealing with point of intersection, it means these two graphs, they are equal at the point of intersection. That is what you're supposed to know. As long you are working with point of intersection, the two functions, they will be equal. So it means in this case, we are saying that f of x will be equal to gx at the point of intersection. That is at the point of what? At the point of intersection. This is intersection. We are saying these two, they will be equal at the point of intersection. So you can simply equate the two, f of x and gx, just equate them. So remember, we had 2 minus x bar, which is equivalent to gx, and our gx was a third x. So this is a third x plus what? Plus 1. So that's the equation for us to solve. So in this case, we can just make this x bar to be the positive. So you can transpose here 2. Transpose this to the left-hand side. It's going to be minus a third x. Transpose 1 to this side is going to be -1, which is equal to x bar, which is now equals here. Just avoiding to work with a negative. Okay, so 2 minus 1, that is 1 minus a third x, which is equivalent to x bar. So to remove the bar here, the modulus, we square. So this is x squared that you are going to have, and this part you also square. So it's going to be x squared. So expanding x squared, we are going to, okay, well, before that, we expand, we can actually, yes, we can just expand, it's fine, but we can factor out a third so that it can be easier for us, because if I factor out a third here, it's going to be 1 divided by a third, which is 3, minus a third, and a third is going to be x squared. Okay, and not x squared, is still x there. The bracket is actually outside of this. Okay, so here let me just remove this part so that it can be clear. The bracket is going to affect everything like this because we have factored out a third. So this 2 is going to be affected like that, okay, which is equal to x squared. Now we can expand the brackets. That's 1/3 to the exponent of 2, which is 1/9 into 3 minus x to the exponent of 2, which is equal to x squared. So here we can actually expand our brackets and see what you're going to have at the end. This is equal to, so we are going to have 1/9 into, if we expand this, it's going to give us 9 minus 6x plus x squared. So this is x squared, which is equivalent to x squared. Okay, now let us collect like terms, and we can, before that, let us just expand the brackets. 1/9 times 9, that is 1 minus, but why are we expanding these brackets, guys? It can be difficult for us, isn't it? It can be difficult. Let's just get rid of this 1/9 by just multiplying by it. I can see that this can be difficult for us too. Yes, it's fine, but why do we want to? Let's just put it this way. This can cancel here. Okay, so this will be 9 there. At least that way it can help us to avoid even working with fractions. So we're going to be left with 9 minus 6x plus x squared, which is equal to 9 times x squared, which is 9x squared. Okay, so now we've got a normal equation that we've got. So this x squared here is going to be 9 minus x squared, which is 8x squared, minus x here is going to be plus 6x 9 to this side is going to be minus 9 is equal to 0. So now you're left with the normal equation. Use your factorization, find factors, or just use your quadratic formula, or you can just find factors of minus 72x squared. If you multiply this, it's going to be something like negative 72x squared. So therefore the factors, we have got 12x and what? 12x and minus 6x. We can actually work with these two factors. That's 8x squared plus 12x minus 6x minus 9 equal to 0 here. So factor out 4x. Yeah, 4x is actually common here. That's going to be 2x plus 3. If we factor out, it will be minus 3, so that it can give us a positive, which is actually 2x plus 3. And this everything will be equal to 0 here. Take one of the brackets, which is the same. This part, guys, is going to be 2x plus 3, and the part of 4x minus 3, that's 4x minus 3, which is equal to 0 here. So each bracket is equal to 0, so therefore x will be minus 3 over 2, or x is going to be a positive 3 over 4 by transposing each and every part, or x is going to be 3 over 4 in this case. Okay, guys, so that's how actually you end up with these typical questions actually. So it's a matter of understanding the question that you are given, and also an application of formulas, one that you are given, and always try by all means to apply the best way in your solving of equations. I don't know the method that you are good at, but always try by all means to use the best method that you have. So the question now was to find the point of intersection. So these are the values of x that we have at the point of intersection. So, but remember that a point is actually referred to with x and what? With x and y. So with the values of x, we can substitute into n of these two equations, because we say they are equal. We can substitute into a third x plus 1. So the value of y is going to be, if we substitute there, because y is equal to a third x plus 1, you substitute into n one of the equations. So x is, if x is minus 3 over 2, we are going to have 1 over 3 times minus 3 over 2 plus 1 in this case, or the value of y in this case is going to be 1 over 3, and our x in this case is 3 over 4, so it's going to be 3 over 4. Whatever that we have, we add a 1 in this case. So the first one, y is going to be, if you substitute the one of minus 3 over 2, minus 3 over 2 is going to give us 1 over 2, or in this case, y is going to give us, from 3 over 4, we are going to obtain 5 over 4. Okay, so therefore the point of intersection, in this case going to be the first one, x with minus 3 over 2. So it's going to be minus 3 over 2, and y in this case was 1 over 2. So this is a point now. And the other point is when x is what? When x is 3 over 4, like that. When x is 3 over 4, or y was 5 over 4. Okay, this is 5 over 4, guys. Take note. This is 5 over 4. It senses too much, this thing. It actually senses too much. But this is 5 over 4. Okay, so that's how you actually attempt these typical questions, guys. Mind that whatever that you're given, you are supposed to work properly, but that's what we had from this part. So like I said, we shall meet again, guys, in another episode or in another class, now working on the other questions, so that we'll be able to finish out the whole of this question paper from Meson African Motives, working on A-level mathematics, past exam papers and revisions. As we are preparing for the exams which are ahead of time, let us continue to work as much questions as possible, because we do not have time. We do not have time at all. So that's it, guys. Till we meet